Hi everyone, I am the founder of the Grey Blind Owl. In this lesson, we will examine decision structures and discuss how to use them. Decision structures are available in all programming languages, and their usage is almost the same across all. In my opinion, it is not correct to examine decision structures under a separate heading as if they are a feature of a language. In fact, we use all the decision structures hundreds of times in a single day apart from software world. If I do not tell before I leave the house, my family will be worried about me. This is a very common structure for us, and it will be a common usage for our program, just like this sentence and our daily decisions. At this point, I want you to think that we have created a perfect, error-free judge that we want to run smoothly. Right now, he or she is just a baby. But he or she is a baby who understands everything we say at once and never forgets it. We will tell her or him everything step by step, and he or she will reach perfect judgment by following these steps every time. Imagine our compiler is a baby like in the same example and plan to make it a judge. If you tell her or him what is right and wrong with the right expression, you will have raised an excellent child. In short, decision mechanisms help us a lot in writing highly branched and complex programs that can make decisions for us. I want you to focus on the if, else structure. It is the most important and critical thing in this sample code. If, else structure. This structure is completely the same with our classical daily if word. If we want to add an extra if statement in the same flow, we use else if block. Else if block is not necessary, it is optional. If we want to mean a completely different statement from other statements in the if and else if blocks, we use the else block. Please forgive me if you did not understand me, and do not worry about this, I will help you immediately. Usage. If statement, our condition here, curly brackets, and the comments. Else if, the condition, curly brackets, and comment. Else, curly brackets, and comment. Switch and case structure. Switch structure is like if structure, but it is more complex than if structure. We generally do not use it a lot like if, but sometimes we solve a problem with this structure easily. Its usage looks frightening, but its logic is very simple. Usage, switch, variable, and the curly brackets, case, value, colon, command 1, semicolon, break, and semicolon. You can use multiple command lines here. I give an example, only one comment here. Case value, colon, operation 2, semicolon, break, semicolon. Case value, colon, operation 3, semicolon, break, semicolon. Default, colon, operation 4, and semicolon. We do not have to use break comment here. We do not have to use break comment here because default comment the last comment, our switch case structure. Switch case structure is finished here. Switch case structure is finished here. So we do not have to break comment. This is our last comment. Okay, if your value is the same with the variable value, this operation will be run. This operation will be run. For example, if your third case value is equal to 3, the value is equal to 3, and your variable also is equal to 3, the operation 3 will be run. Okay? Not operation 2 because value is equal to 2, not operation 1 because the value is equal to 1, and they are different from the our variable value. So the third case will be run. The third case will be run. And break. Break means, hey compiler, my command is finished and we do not have to run other commands in this switch case structure. For example, default, case 1, case 2, or maybe case 4, case 5, for example. Okay, this is the switch case structure. Go to command. Actually, I was undecided to mention this command because it may lead some problems in your big scale program and its using is not completely legal. There are a lot of discussion about this command, but I am a mirror in this condition and I have to show every detail to you. Nevertheless, I want you not to make this command a habit because you will be able to do everything that you can make with command with the loops. Go to command uses with a label. This label can be called as you wish, and when compiler reads this command, it goes the label line. In any other using method, if you want to create an endless loop that finishes when your conditions are provided by user, you can use the command. The second using is more popular than the first one. However, as I mentioned, please do not make this a habit. Usage. Command 1, semicolon, command 2, semicolon, blah, 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 blah. Label name, colon, label name, colon. Command 3, semicolon, command 4, semicolon, and go to command, label name, and semicolon. We go to the label name. And we continue. Command 3, semicolon, command 4, semicolon, go to command, label name, semicolon, and we go to label name, colon, command 3, semicolon, command 4, semicolon, go to command. As you can see, we are in an infinite loop. We are in an infinite loop. This is the go to command. Now we will do some exercises about the if, else structure, switch case structure, and go to command. And here we include our library. Hashtag include brackets stdio.h. We create our main function, int main brackets and the curly brackets. We create our some test variables for the examples, integer, x, and square, and semicolon. We get the x value from the user. Printf Please enter a positive integer number, scanf, the person sign D, X, and semicolon. Now we create an if block here and we write our condition between the brackets. If X is less than 4, curly brackets, printf, X is smaller than 4, and semicolon. Else if X is bigger than 4, X is bigger than 4, the curly brackets, printf, X is bigger than 4, and semicolon. Else, the curly brackets, printf, X is equal to 4, and semicolon. Because if the X is not less than 4 or X is not bigger than 4, so means X is equal to 4. Printf, X is equal to 4 and semicolon. Okay, let's try. Please enter a positive integer number. I try this if X is less than 4. I will enter 3 here. As you can see, X is smaller than 4. X is smaller than 4. Okay, let's try again. I will enter this time 4. Sorry, I will enter 5 because I try as if X is bigger than 4. I will enter 5 and enter. X is bigger than 4. As you can see, X is bigger than 4. X is bigger than 4. Okay. I will try for 4. I will enter 4 here. I will try else. Printf, X is equal to 4 because I will enter here 4. As you can see, X is equal to 4. Okay, this is the if block. This is the if, else if, and else structure. Now I will give a critical info about the equality. If we use if or else if blocks and we want to check an equality, we cannot use only one equality sign in the statement region. Okay, we cannot use only one equal sign in the statement region. We must use double equal. We must use double equal signs in the condition. As you can see, if X is equal to 4. Okay, not only one. This is wrong. We will enter double equal sign here. Printf, X is equal to 4. Let's try. I will enter 4 here. As you can see, X is equal to 4. Now we will create a switch case structure. We create a switch case structure here. Switch X, and our X value is equal to 2. Switch X, curly bracket, case 0, colon, printf, variable value 0, and semicolon, break, semicolon, case 1, colon, printf variable value 1, and semicolon, break, semicolon, case 2, printf variable value 2, semicolon, break, semicolon, default, colon, printf variable has a different value, semicolon, and the curly bracket. Let's try it. Compile and run. variable value 2. Here, case 2. Case 2. Printf variable value 2 and semicolon. As you can see, variable value 2. Because the case number 2 and our variable value is equal to 2, so they are the same number. They are the same number. So case 2 is active now. The case 2 is active now. So we will see on the screen variable value 2, as you can see. Okay, if I change this value with 1, for example, and compile and run, as you can see, variable value 1. So the case 1 is active. Printf variable value 1. Okay, if I change this with any number, not case numbers, case 0, case 1, case 2, not these ones, and I want to enter 8 here, for example. Okay, as you can see, variable has a different value, so our default case will be run. Printf variable has a different value because the 8 number is not equal to any case number here, as you can see. Okay, this is the switch case structure. This is the switch case structure. Now we will use go to command here. We create a label enter, and I want only positive numbers. I want only positive numbers. Okay, I want only positive numbers. Enter label here, colon, printf, a blank, a tab, actually a tab, printf, number, scanf, the person sign D, ampersand x, semicolon. If x is less than 0 or x is equal to 0, go to enter label, and do the operation again. Printf, number, scanf, the person sign D, ampersand x, semicolon. If x is less than 0 or x is equal to 0, go to enter label again and get the process. Okay, if everything is okay, square is equal to x times x and semicolon, printf, square is equal to person sign D, square, semicolon. Let's try it. Execute, compile and run. Okay, please enter a positive integer number. If I enter here 0, number, if I enter here 0, as you can see, ask again, number. The compiler asks us for number because our condition here, if x is equal to 0, go to enter. And enter printf, number, scanf, the person sign D, x. Okay, if I enter here a negative number, for example, -1, as you can see, the compiler asks again because our condition, if x is less than 0, go to enter. Okay, I have to enter a positive number. I have to enter positive number this condition. The user has to enter a positive number this condition. Okay, so I will enter 2 here. As you can see, square 4. Square x times x, semicolon, printf, square, the person sign, D square, semicolon. Okay, that's all. Return 0. We finish our program here. That's it for this week. You can find this code file below this video as every week. You can also get some exercise instructions in the description section for you to do until next week. Thanks for your patience and effort. See you next week. Stay tuned.